this section we're just going to introduce the terms that are going to be used, and then we'll go into more details in them in separate chapters. So as far as triangles are concerned, okay, there's several classifications for triangles, either by side or by angles. If we're looking at classification by side, these should be familiar terms to you. But an equilateral triangle, and you can look at the illustrations, the tick marks on here indicate equality. And so it's an unspecified value, but you can see by the corresponding tick marks that that value is the same for each side. So again, this 2 tick marks represents a different length than 1 tick mark, but the fact that they're all 3 the same unknown value means that you still have this equilateral triangle, which is 3 sides of equal length. Okay, so equilateral triangles, all 3 sides are equal. Now, in an isosceles triangle, its 2 or more sides are equal. So what that means is, would equilateral triangles be considered isosceles? Yeah, it fits into that category. Now, again, depending where you are, who's teaching a course, some will distinguish between the two. And historically, they were distinguished. Isosceles and equilateral were separate things, but the more common practice is to include isosceles as 2 or more equal sides. So that means that all equilateral triangles fall into this category. And then finally, scalene means that there's no equal sides. Right. In addition to classifications by sides, there's also classification by angle measures. Right. And so the angles are classified just like how we classified our individual angles as well. If you have a right triangle, that means that there is one right angle in the triangle. Can there be more than one? So what is the sum of the angles in a triangle? So in a triangle, 180, right? So that means that if you had 2 right angles, would there be any degree measures left for that third angle? No. So you can only have 1 right angle. If you do, it's called a right triangle. An obtuse triangle can have 1 obtuse angle. Based on the same logic, is it possible to have 2 obtuse angles? No, because then that would be greater than 180, and it wouldn't form an enclosed figure. And then finally, an acute triangle has only acute angles. All right, so when you're dealing with this type of classification, you can expect to get questions pertaining to sometimes, always, or never true. Right? And so I might say something to the effect of it's possible, or a triangle has 2 right angles. Sometimes, always, or never true. Never true. A triangle has an obtuse angle. Sometimes true. What about a triangle has 2 acute angles? Think about it. So a triangle has 2 acute angles. Okay, so always, right? Because in a right triangle, does that have 2 acute angles? In an obtuse triangle, does that have 2 acute angles? And in an acute triangle, does it have 2 acute angles? Yeah, there's an additional one as well, but it does. So make sure, again, if you're given those types of questions, you look for counterexamples and examples. If you can only find examples, it's always true. If you can only find counterexamples, it's never true. And if you find both, then it will be sometimes true. Okay, when you're classifying as well, you'll classify by sides first and then angles. So again, is it possible to have an isosceles right triangle? Okay? So it can have a right angle and two equal sides. Now, is it possible to have a scalene acute angle or triangle?
Yes.
Yeah, in fact, you see an example of it right here. 1 tick mark, 2 tick marks, 3 tick marks. Okay, is it possible to have an equilateral right triangle?
No.
No, because an equilateral triangle has to be what? Well, so since all the sides are equal, all the angles will also be equal in this specific figure, which means in this case, what would each of these angles be? Again, even though we'll specify this in more detail in Chapter 5, most of you are familiar with that relationship. So if all the angles are 60 degrees, then you have an acute triangle. All right. So what I want you to do is just take about 1 minute, see if you can answer these questions. Again, you can either write them down or just make sure that you've looked them over. Looking at these, you can just kind of call them out. Classifying triangles based on sides. A triangle with sides of 5, 4, and 6 inches would be classified as no equal sides, so scalene. And what about 8, 8, and 8? Okay, and 3, 5, and 3? Okay, now, what if I told you that this is only partially right? Anybody see what's missing here? Jenna?
On the second one.
Okay. So remember to be very careful that you include all possible classifications for anything that it asks you. And in this class, we are assuming if something is equilateral, that means it's also going to be isosceles. And so you would need to include that if it were a multiple choice type of question and it said choose all that apply. The expectation is you put equilateral and isosceles for this. Again, be really careful. Make sure you read the problems carefully. Don't read anything into it, but make sure that you read it carefully. All right. Let's look at the second example here. And classify based on angle measures. Okay, 40, 50, and 90 is a right triangle. 140, 20, and 20 is obtuse triangle. And 60, 60, 60 is acute. Now, is it equilateral based on its angle measures? Based on angle measures. I mean, it is true that it is equilateral, right? But if you're classifying it by its angle measures, would you need to mention anything about its sides? No. Because looking at this one, if you know properties of triangles, this also happens to be an isosceles triangle, right? If you're familiar with that. But it's not asking you to classify by sides. So in something like this, you would only want to include the classification of acute.